All right, so Google has just dropped its next generation of OpenAI models. We're talking about the new Gemma family. And look, these are not just some small incremental updates. No way. This is a major leap forward in terms of power, flexibility, and who can actually get their hands on this stuff. So let's dive right in and really unpack what makes this release such a huge deal. So here's what we're going to cover. First, we'll properly meet the new Gemma family. Then, we'll get into the different models you can choose from and explore their brand new superpowers. After that, we'll put the numbers to the test with some benchmarks, see how you can start playing with it yourself, and wrap up by talking about why open models like this really matter. Okay, let's get right into it. What exactly is this new generation of Gemma? And why is pretty much everyone in the AI world talking about it right now? At its heart, the definition from Google DeepMind is super simple. It's not just one model, it's a whole family of them. But the most important word on the slide? It's open. That means developers, researchers, and creators get way more access to build and experiment with some seriously state-of-the-art tech. And believe me, this new generation is a huge leap. We're talking true multimodality. It can understand text, images, and audio. It has a mind-blowing 256,000 token context window. You can just think of tokens as the building blocks of information it can process. Plus, its ability to reason and write code has gotten a massive upgrade. And the best part? It's built to run on pretty much anything, from the phone in your pocket to a giant cloud server. Now, one of the most fascinating things about the new Gemma family is that it's not a one-size-fits-all deal. It gives you different architectures for different jobs. This is all about picking the right tool for the task. And the two main flavors are what we call dense and mixture of experts. Let's break down that second one, mixture of experts, or MOE for short. Imagine you have a team of specialists. You've got a math genius, a language expert, and a coding guru. Now, instead of bothering the whole team with every single question, an MOE model is smart enough to route your question only to the experts who can actually help. This makes it incredibly fast and efficient. So here's the key difference. A dense model is like a brilliant generalist. It uses all of its brain power for every single task. It's incredibly powerful, but that can take up a lot of resources. The MOE model, on the other hand, is that specialist team. It only calls on a small fraction of its total knowledge for any given task, which makes it super fast and efficient. And this table here lays out the whole family for us. You've got the smaller, dense models, the 2B and 9B, which are perfect for running directly on your device, like in a mobile app. And heads up, these are the only ones that can handle audio right now. Then you've got that super efficient MOE model, the 27B. It has 27 billion total parameters, which you can think of as its total knowledge, but it only uses a little bit at a time, perfect for snappy, scalable web services. And finally, you have the heavyweight champion, the 32B dense model. That's for when you need maximum raw power for deep research or really complex creative work. All right, now for the fun part. Let's take a look at the incredible new capabilities that are packed into this new generation of models. These are the superpowers. There is so much to be excited about here. There's a new thinking mode for really complex reasoning. Like we mentioned, it's truly multimodal, juggling text, images, audio, and even video frames. That context window is just massive. Its coding skills are night and day better, and it has native support for function calling. Now that's the magic that lets the AI connect to outside tools, like say looking up live flight prices. It's absolutely essential for building the next generation of powerful AI agents. Let's just pause on this number for a second. 256,000. That is the token context window for the larger new Gemma models. But what does that actually mean for you and me? It means the model can basically hold the entire text of a 500-page book in its working memory all at once. It can analyze it, cross-reference it, answer any question about any detail, and it won't forget what happened on page 1 by the time it gets to the end. For complex document analysis or research, that is an absolute game changer. And remember, it's not just about text. This is true multimodality. The new Gemma models can chew through text in over 140 languages, analyze images, understand video by looking at the individual frames, and on those smaller models, even listen to and process audio. You can literally throw all of these different things into a single prompt and it'll figure it out. So, the features sound amazing, but talk is cheap, right? Let's get into the hard data and see how this new generation actually stacks up in performance benchmarks. Wow. Okay, just look at this chart. This shows the incredible leap in coding ability. On this specific test, the last generation scored about 29%. The new flagship model, it scores an unbelievable 80%. That's not just a little bit better, that is a revolutionary jump. For developers, that is a massive, massive upgrade. And this chart is a perfect snapshot of the performance range across the family. On a really tough reasoning test, the 9B model, the one designed to run on your laptop, scores a super respectable 69%. But the biggest 32B model, running on a powerful server, pushes that score all the way past 85%. You get to choose the perfect balance of power and efficiency for whatever you're building. Okay, so you've seen what it can do, you've seen the numbers, so how can you actually start using it? Let's walk through the basics and some key tips for getting the best possible results. You know, the process is designed to be pretty straightforward for developers. From a high level, it really boils down to 3 steps. You set up your coding environment with the right libraries, you write a couple lines of code to load the specific Gemma model you want, and then you just start sending it prompts and getting results. But to really squeeze every drop of performance out of it, there are a few pro tips. For best results, always put your images or audio files before the text in your prompt. For really tricky problems, make sure you turn on that special thinking mode. And in a back-and-forth chat, don't feed the model its own thought process back to it. Just give it the final answer. Little tweaks like that can make a huge difference. So for our final section, let's zoom out, because releasing a model this powerful under an open license isn't just a technical update. It has much, much bigger implications for the entire field of AI. This slide really lays out the 2 sides of the coin. The promise of open models is enormous. They democratize access so anyone can build with top-tier AI, they supercharge innovation, and they make the whole field more transparent. But there are real risks. They can pick up unwanted patterns from their training data, and just like all models today, they can be factually wrong or used in ways they weren't intended for. So the crucial point here is responsibility. According to Google, these new Gemma models went through the same intense safety checks as their closed proprietary models. The training data was carefully filtered to remove sensitive information and other harmful content, all in an effort to get ahead of these risks from the very beginning. And that brings us to our final question. With open models as capable as this new Gemma family, state-of-the-art AI is now more accessible to more people than at any point in history. It's this incredible moment of both opportunity and responsibility. And the big question we're all left with is, what happens